Hey everyone, welcome to today's Explainer. I'm your tutor, and we are going to be diving into a super fascinating chapter today for your Class 8 CBSE syllabus, Natural Resources. So grab your notebooks, get comfortable, because we're going to break down some major concepts that are absolutely crucial, not just for acing your exams, but honestly for understanding the world right outside your window. Let's jump right in. Here's a quick look at our game plan for today. We'll be defining what natural resources actually are, comparing renewable and non-renewable ones, looking at how they're distributed, exploring the real costs of overexploitation, and finally wrapping up with stewardship and sustainable solutions. All right, Section 1, defining our natural resources. Let's start with the absolute basics. What actually turns a piece of nature into a usable resource? Now, nature is literally all around us, but for your exams, you need to remember this exact definition. It's actually not a natural resource unless it checks three very specific boxes. First, we have to actually have the tools to reach it, meaning it's technologically accessible. Second, it has to make financial sense to dig it up or collect it, so economically feasible. And third, society actually has to be okay with us using it, meaning it's culturally acceptable. Think about it. If there's petroleum trapped so deep under the ocean floor that it costs way more to extract than we could ever sell it for, or we just don't have the drills to get to it, well, it's not currently a resource. To make studying a whole lot easier, we basically toss natural resources into three clear buckets. Bucket number 1, the absolute essentials for life. We're talking air to breathe, water to drink, soil for growing food, stuff we literally need to survive. Bucket number 2 is materials. These are the physical gifts from nature that we use to build and shape our world, from the wood in your desk chair to golden jewelry. And the third bucket is energy. This is the fuel powering our modern lives, like coal, petroleum, sunlight, and wind. Okay, time for a quick tutor's checkpoint. Let's test what we just learned about that definition. Imagine a community has a sacred grove of trees. Can a logging company just come in, chop them down, and classify that wood as a natural resource? What do you think? The answer is a hard no. And this is a brilliant example of how human culture actually dictates what we consider a usable resource. Because those trees hold sacred value to that local community, harvesting them is simply not culturally acceptable. So in that specific context, those trees are totally off limits. They are not an extractable resource. Moving right along to Section 2, renewable versus non-renewable, let's see how resources are actually replenished over time. For your exams, here is the best way to visualize this. Think of renewable resources kind of like your own skin. If you get a small scratch, your body kicks into a restorative cycle and heals itself, right? A forest recovering after a wildfire acts the exact same way. It naturally regenerates. Non-renewable resources, on the other hand, are basically like a bank account with a fixed amount of cash that takes millions of years to refill. When we burn fossil fuels like coal and petroleum, we're spending that cash way, way faster than nature can deposit more. Once the account is empty, it's just empty. All right, another checkpoint. This is a huge conceptual question that examiners love to ask. How can something that is legally and scientifically categorized as renewable suddenly become non-renewable? Here's the secret. Renewable does not mean infinite. It's all about the speed of use. If we pump out groundwater much faster than the monsoon rains can possibly refill it, we break nature's cycle of restoration. We literally outpace the planet's ability to heal. Let's transition to Section 3, distribution and resource curse. We know what resources are, but now let's look at how they're actually spread out across the globe. When you look at a map of India, or really anywhere in the world, you'll immediately see that resources aren't just sprinkled evenly. Some regions are absolutely packed with coal, oil, and iron ore, while others have practically none. And this uneven distribution is a massive deal. It dictates where humans build major cities, how global trade operates, and historically, it's been the root cause of countless wars. But surprisingly, this uneven spread leads to a totally counterintuitive economic concept. Make sure you write this one down. It's called the natural resource curse, or the paradox of plenty. It's this bizarre phenomenon where countries sitting on massive gold mines of natural resources actually experience slower economic growth. Sounds crazy, right? But here's why. They often just sell off the raw materials and totally fail to develop the local skills, technology, and industries needed to turn those raw materials into higher value finished products. Basically, having resources doesn't automatically make your country rich if you don't build the infrastructure to truly utilize them. So let's see if you caught the textbook's specific stance on this. Where does our country fit in? Does India suffer from this paradox of plenty? Thankfully, the answer is generally no. India has pretty successfully dodged this curse. Instead of just exporting all our raw materials overseas, we've used strategic planning, human knowledge, and good governance to invest heavily in developing our own local industries. We've used our natural wealth to build our own economy. Okay, Section 4, the cost of overexploitation. We need to talk about a very real, very serious historical cautionary tale from your syllabus. What actually happens when we push nature too far? Let's travel back to the fertile plains of Punjab during the 1960s Green Revolution. Farmers made a massive shift to high-yielding varieties of wheat and paddy. And initially, it was a miracle. It helped make India totally self-sufficient in food. But there was a hidden cost. These new super seeds required a ridiculous amount of water compared to traditional crops. So, fueled by free power provided by the state, farmers started over-pumping groundwater using heavy modern extraction techniques, just flooding their fields to keep up. And the long-term consequences of breaking that restorative cycle are staggering. By June 2022, nearly 80% of Punjab's area was classified as overexploited. Groundwater levels have plummeted to inaccessible depths of 30 meters. Remember our bank account analogy? They treated a renewable water supply like a non-renewable bank account, and now the account is running desperately dry. Let's pause and think about the inputs those high-yielding crops needed. It wasn't just water. What dual hazards were created by this style of modern farming? You guessed it. The first hazard, obviously, was the severe depletion of groundwater. But the second, which is so often overlooked, was intense chemical pollution. Modern farming relies heavily on chemical pesticides and fertilizers. Over time, those harsh chemicals seeped deep into the soil and dissolved right into the shrinking groundwater supply. So not only did the water run out, but the little water that was left became toxic. Finally, Section 5, Stewardship and Sustainable Solutions. Now don't worry, it's not all doom and gloom. I want to show you how ancient wisdom and modern innovations are stepping up to solve these exact problems. We just saw the crisis in Punjab, but look at the incredible, uplifting story of Sikkim. Farmers there were also facing declining crop yields and getting buried in debt from buying expensive chemical fertilizers. Recognizing the crisis, the state government aggressively promoted organic farming. It was a tough transition, sure, but farmers went back to using traditional compost and created natural pest repellents out of everyday things like neem and garlic. The result was phenomenal. By 2016, Sikkim made history as the world's first 100% organic state. Biodiversity bounced back, ecotourism exploded, and farmer incomes actually jumped by 20%. It is the ultimate modern case study in environmental stewardship. And you know, being an eco-friendly steward isn't some brand new modern trend in India. It is a deeply connected story spanning centuries. Way back in the 10th century, a scholar named Surapala formalized Vrikshayurveda. This was an ancient Sanskrit science detailing sustainable agriculture, crop rotation, and soil health centuries before modern science caught on. Look at the 12th century. The majestic Jaisalmer fort was built purely from mud and stone, proving we've always had incredible, durable alternatives to highly polluting modern cement. Fast forward to 2015, and India co-launched the International Solar Alliance with France, leading the global charge toward renewable solar energy. Our ancient wisdom is perfectly aligning with our modern solutions. I want to wrap up our explainer today by leaving you with a really profound thought straight from your textbook. The Bhagavad Gita talks about lokasangraha, the powerful idea that we have to look past our own short-term selfish desires and act for the collective well-being of the entire world. When we choose to protect our groundwater, manage our minerals responsibly, or switch to solar power, we are quite literally practicing lokasangraha. So as you study for your exams, I want to leave you with this question. Are you ready to use your education to become a true steward of our planet? Thank you so much for joining me today, class. Go review your notes, and I will catch you in the next lesson.